Block letter printer. Okay, write a function that accepts a string consisting of only Ascii letters and spaces and returns that string in block letters of 5 characters width and 7 characters height. So something that looks like this. Given this input of hello world, we get block letters in the output. So the solution to this most people would come up with is pretty obvious. You copy and paste say this whole block of letters that are the block letter representations, and then you'd have like a mapping between each of these letters to a section of this mapped area. So I'm not exactly going to be doing that. I'm going to be doing something a little bit different that takes a bit of a unique spin on this problem because I noticed something that I think is quite an interesting way of approaching the problem. So without further ado, I'm going to get right into it. So, as I said I wouldn't be doing, I've copy and pasted the big old block of text into my solution. Now, it's not going to stay there because I'm going to do something. And I started looking at this and I just wasn't happy with having this giant block of text in my solution. And I thought, well, how can I compress that down? And it occurred to me that each column of text it consists of essentially 7 rows. And if you think about the size of a byte is 8 bits. And you've essentially got bits of information here. You've either got a blank space or a non-blank space. So you could represent this as a series of zeros and ones. And then if you take that entire column of zeros and ones, that could be expressed in a byte of data. And a byte of data maps quite neatly to an ASCII character. So this whole block of text can be essentially compressed down into a single line of ASCII characters. So I thought, hey, that's something a bit different. I'll do that. And it ended up quite a small and concise solution. So I will show you what I did. So the first thing I did was to write a function to get one of these individual columns of text. Okay, so I've written the function and it accepts a value for the specific column that's going to be some value between 0 and whatever the length of this row is, which I guess will be expressed by that. Actually, it will be 26 letters multiplied by 6 characters for each letter, including the space. Not -1, because I've got a space on the end as well. And then 0, 1, 2, all the way through to 6 for each of the rows, and map each row index to the relevant square or character from this string. So R is the row times 26 times 6. So that's going to be some value, the length of the row. So it will iterate over the character positions along this column. Plus n, of course, gives us the offset. So it's like the x value. So yeah, that's like the y value. This is the x value. So if I execute this with 0 in here, it should give us this first column. Let's see if it works. Which it does, I think. So yeah, space A. And if we were to pass in, say, I don't know, something a bit more interesting, maybe column, well, let's just do column 1, actually. Column 1 is A space A space, which matches with this. So our function appears to work. Let's just do 26 times 6. 25 times 6 plus 1, which I guess should be the first column of the Z. Yeah, Z space Z space Z. Oh, okay, so it must be this second column, actually. Yeah, because it's 0 based. Therefore, that would be the first column of the Z. Z space, 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 Z, Z. Good. Now that we've got that column as text, we can just map whether or not we have a letter in the relevant character position to either a 0 or a 1. So if it's a space, then it maps to a 0. And if it's a letter of any sort, then it should map to a 1. So pretty straightforward. We take n, we pass it through to the getColumn function that we just created. And now, based on the array of letters we get back, we do a map. And for each letter, we check, is that letter an actual letter or is it a space? If it's not a space, then we treat it as a 1, convert it to a 1 with this, we coerce the truthy value to a 1. And we coerce a falsy value to a 0. So that then maps all of those to a 0 or a 1, and then we join them together with an empty string. So using the first column of the Z that we used earlier, let's just see what we get in the output. So yeah, again, we get 1, 0, 0, 0, 0, 1, 1, which corresponds nicely with Z space, 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 Z, Z. So now that we have it as a binary number, we can convert that binary number to a decimal number and then feed that into a function to convert that number to an Ascii character. Okay, cool. So got a function now, getColumn Ascii, which will accept a column and return the Ascii representation of the column of characters. So I get the column binary representation and I'm passing that into the parseInt function to convert that binary number into an integer, passing a radix value of 2 here. So that just tells the parseInt to treat the input as a base 2 number, so a binary number. So then we get the integer value converted from binary, and then we can just take that value, which will be a value between 0 and 255, into the string.fromCharacterCode function, which will then give us the character from that specific value that we pass in. So again, if we run it for that column of text, what do we get? The letter C. Ah, isn't that nice? So that means that this combination of 1, 0, 0, 0, 0, 1, 1 is the letter C. And we can look that up. If we just go to a Ascii table and find the character C, wherever that may be, letter C, blind. Here we go. Yeah, C. Right. So decimal value is 103. Now I have something I prepared earlier that I plan to use later. 103 equals 1100111. Now that doesn't add up then, does it? What have I done wrong? Oh, I took the oct one, so it's actually 67. Okay, 67. Yeah, there you go. 1000011. So that corresponds with 1000011. So the letter C captures the data for that column nicely. So now I've just written some code to basically loop over each of the columns and output the Ascii character for that individual column. Just output that as a big long string. And if I run that, we get it here. So I'm now going to copy and paste that into my solution. Let's just make this bigger. Paste that there. And I can now delete all of this code because it's no longer needed. don't need this. And now I can build a solution based on this encoded version of the text block that is now no longer a block. It's just a nice compressed chunk of data that we can use. So as I've already explained, the encoded text is an Ascii representation of each of the columns. So if I take the last 5 characters, this is the group of 5 characters that represents the letter Z. So I can paste that into this Excel spreadsheet that I've created. And all this is doing is taking the first character with this mid function and using this code function to convert the character into its decimal numeric value, which is 67 for the letter C. Now, if I look up the letter C, Ascii table, just just show on this table. So here you've got the letter C, make that a bit bigger, and yeah, you can see decimal representation of the Ascii character uppercase C is a 67. So yeah, that's all this is doing. And if we call the dec to bin function, that just shows us the binary representation of that number. And I've done some work here just to show that if we take the bitwise AND of this number and the various powers of 2, we can extract the bit, whether or not the bit is turned on or not, for each of the characters in that binary representation of that number. So 64 represented as binary is this, 32, 16, 8, 4, 2, and 1. And if you take the bitwise AND, it will check the corresponding bit in the number that you're comparing it with, and only where there is a 1 and a 1 in the two numbers will it return that in the result. So here we get a result of 64 because that is the only bit that matches between these two binary numbers. And you can see with 32 does not match. 16 does not match. With 1, it does not match with the 67. With 4, it does not match. However, with 2, this bit matches with this bit. So therefore, we get 2 here. And here, this 1, so 2 to the base 0, I think that is. Yeah, 2 to the base 0, which is 1. Sorry, to the power 0. Yeah, again, matches with that 1, and we get a 1 here. So if we convert these into truthy values, this corresponds with this first column, just to illustrate what I'm doing to convert this back into a block of text. And yeah, this is exactly the same as this column. So what I'm doing with these other columns is with this mid function, I'm now using the value 2 to extract the second character, and yeah, 3, 4, and 5 for each of the character positions. And you can see that if we convert this grid here into a truthy grid, I suppose, where it's either on or off, you can see we get the letter Z coming out the other end. So similarly, if I just go and copy paste a completely different letter, maybe, I don't know, the first one, paste that in here, it's going to do the same operations. So the value of the first character here is 63, which is 0, 1, 1, 1, 1, 1, 1. May have done the wrong number of ones there, but you can see how this corresponds exactly with this first column. And if I was to maybe, let's take the second character just to illustrate what happens with the letter H. So here we've got 1, 0, 0, 1, 0, 0, 0, and that corresponds exactly with this column, 1, 0, 0, 1, 0, 0, 0. So that's the kind of solution that we're going to have to implement in code, and I will just get on that straight away. So the first thing I'm going to do is I'm going to take this input and I'm going to convert it into a longer version of that same input by just repeating the character 5 times and have a space in between those, so that it's, broadly speaking, going to be the same length as the result that we're going to want to produce at the end. Okay, so I've got the input. I've just changed it to a different letter, T for template, because this is going to be kind of like a template row. And I'm just converting the input to uppercase. I'm doing a replace of dot, so I'm replacing each of the characters with a function call. So this comes through as each of the characters, and it will be replaced with 5 occurrences of that same letter, followed by a space. And then I'm just going to call a trim on the final result, just to trim off the rightmost padding, because that's just not needed in this in the rules specified for this particular challenge. So if we just run that, we'll see what we get. Yep, so we have hello world, and we get what we expect: 5H, 5E, 5L, and yeah, hello world spread out. So we'll then use that to map to the data that we want. I think what I'm going to do next is I'm going to essentially duplicate the rows so that we get a block of text rather than a single row of the repeated characters. So I'll do that now. Okay, so now we're getting a block for each of the letters: HELLO, space WORLD, but obviously at the moment still doesn't read our big block letters, but we're getting closer. So the way this works is to just iterate over the values between 6 and 0 and map, basically duplicate the entire row. So we get a Y value, which is going to be our row, and we're taking T, which is our template string that we created earlier, and we're spreading that so that we get an array of all the characters and just mapping it. In fact, this is completely redundant then. It's just mapping it to itself and joining them together, and outputting that block of text at the end. So now we're at the point where we can attempt to extract the relevant information out of this encoded string. So I now want to extract the same kind of logic that I'm using here to determine whether to use the character that we have already in our block, where it's either like a block of H or E or L, whatever, and decide whether to keep that letter or to replace it with a empty string. So let's get cracking. So the main point here is where previously I was mapping the character to itself in an unmodified manner. Now I want to control this L and decide whether to have a space or the original character. And I'll do that now. And now we're getting pretty close to the final solution. So here's the output that we now have. Hello world. Not quite finished because I think there's some white space issues we still have to deal with. But if we go to the code that I just wrote, so where previously we were mapping the character, the letter that we have at that specific position to just the same letter, thereby creating a rectangle of that letter. Now we've got some logic that is attempting to extract from our encoded string the information that we want to produce the shape of the letter in the block of text. So this is saying if in our source text we already have a space, then it should remain a space. There's also line endings as well. I think, you know what, actually we don't have line endings at this point. I think that gets added later. Yeah. So yeah, if it's a space, then keep the space. If it's not a space, then we need to decide if we're going. So by the way, that's referring to the spaces between the blocks of characters, like here, for example, this column. If we have that in our input, as we did with the rectangles of letters, then we just keep that space. So otherwise, we refer to our encoded text string. Now, what are we going to do here then? So L. Now remember, L is the letter from the source text. So for the first character position, we're going to be dealing with the letter H. Now with the letter H, just imagine that's the single character H. We do character code at. So this will get the Ascii, the decimal value of that character. So if we go back to this Ascii table and look up the letter H, the value is 72. Now something I should point out, obviously the first value in the alphabet is the letter A. Now if we deduct 65, then A will start at 0, and A through to Z will be the values 0 through to 25. So coming back to here, doing getting the character code and knowing that deducting 65 is going to then give us a value between 0 and 25, that will represent the character in the alphabet. So 0 will be A, B will be 1, all the way up to Z, which will be 25. And that maps nicely on to this big long encoded string that we have, where the characters were defined in order of their appearance in the alphabet. So we take that value from 0 to 25 and multiply by 5. It's going to refer to 0, 5, 10, 15, and go all the way along, and it will map directly onto the first position in the group of 5 characters for that encoded block of text for that character. I think that makes sense. So yeah, it's going to map onto this little group of 5, and then we just add on x modulo 6. Modulo 6 because we have to take into account the space that comes after the group of 5 for the big block version of the text. So yeah, we take x modulo 5 just to get the offset value from here. So 0, 1, 2, 3, 4. Yeah, that's correct. And we skip the last one because of this check here, because the last character is a space. So that then nicely maps on to these individual characters. So we extract the relevant character from our encoded string. Then once we have that, we call this character code at function again to get the value of the character that we've just extracted. So in the example of this first one, if it was the letter A, let's just say, coming back to here, that would return a value of 72. So then up to here, we would have the value 72. I'm not going to be able to find the letter H in here. Well, I suppose I probably can. Let me find it. I'll just zoom through the video. I'll fast forward the video. Okay, this I think is H. So I'm going to copy paste that into here. And voila, we get the letter H. So yeah. Oh, it's the letter 8. Sorry, the number 8 is the letter H. That doesn't sound right. Ah, yeah, sorry, that's mid 2. So that should be 1. That will give us the first one. Now, that's quite interesting. It's all 1s, of course, because the left-hand side of an H is all turned on. So if we just take the first character then, which is 127, And imagine that for the letter H in hello world, this is going to evaluate to the value 127. We're now doing a bitwise AND with 2 raised to the power of y, remembering that y comes from here, and we have the value 6543210. So we've got 2 to the power 6, 2 to the power 5, 2 to the power 4, and counting as we iterate over the y direction. So that maps onto these values. So you can see how we're checking the the powers of 2 to the relevant bits. So we're extracting the relevant bit from the encoded string. And if that results in a truthy value, much as we were doing here by checking that these values are not 0, essentially, here, these are of course 0. If that's truthy, then we return the letter that was there. So in that case, it would be the letter H. Otherwise, we replace the letter H with a space. And that is how it works. So yeah, it's these resolve to a 0 and therefore get replaced with spaces. So I think we're pretty close to the final solution now. It's just a matter of trimming some bits and bobs and tidying it up, returning a value. So I'll do that. Okay, and that's it, really. Yeah, just trimming here. There's a few weird edge cases where you have to return an empty string in certain cases. But that's handled just by doing a trim end at the end of the final solution. And it's a bit weird, actually. I probably wouldn't have done it this way when I created the solution, but created the question. The requirement is that it trims each row. So anyway, I'm doing that here. And yeah, that's the solution. It's pretty concise. And I think it's a lot more interesting than a lot of the other solutions that I saw for this. But yeah, I hope you enjoyed this video, and I think I'm going to leave it there. So yeah, please comment or subscribe if you haven't already, and I look forward to submitting my next video. Catch you later.